Okay, guys, let's pick back up with question 41. Okay, suppose that for a company manufacturing calculators, the cost, revenue, and profit equations are given by the cost function equal to 80,000 plus 30x and the revenue function 200x minus x squared divided by 20, where the production output in 1 week is x calculators. If production is increasing at a rate of 600 calculators per week, when production output is 4,000 calculators, find the rate of increase or decrease in cost, revenue, and profit. Okay, so they gave you some initial information. They told you if production is increasing at a rate of 600 calculators. So that is your change in production with respect to time. It's increasing by 600, and your X, your production, is 4,000. Okay, so we're gonna just put that in our information off to the side. Okay, so part A, determine the rate at which your costs are increasing or decreasing given this rate of production and this rate of increase in your calculator production. Okay, this is your production, this is your rate of increase or decrease of production. Okay, so we're going to take our cost function and we are going to solve for the implicit derivative with respect to time. So we're going to take the derivative of c with respect to time equals the derivative of constant we know is equal to 0 plus the derivative of 30x with respect to time. Okay, so I'm going to pull this 30 out. So the derivative of cost with respect to time is equal to 30 times the change in the rate of production. Okay, so we have this value, the rate of change of production. So our change in cost with respect to time is 30 times 600, and that gives us 18,000. So that's our rate of rate of increase in cost with respect to time at a production of 4,000 with a rate of change of 600. Okay, so then part B, part A. So then part B is asking us to do the same thing with respect to revenue. Okay, so our revenue is 200x minus I lost my function. 200x minus x squared divided by 20. So the same thing, we're going to find the derivative of r with respect to t equals the derivative of 200 derivative of x with respect to t minus the derivative of x squared with respect to t. And this is going to be, okay, 200 times the derivative of x with respect to t minus, we need to take the derivative of the x squared, so that's 2x times the derivative of x with respect to t, and that's our rate of change with for revenue with respect to time. Okay, So now we have this information again. We know the rate of change of production, the dx over dt. Okay, so same thing. We're going to plug in our 600 minus 2. We know x, the production amount, is 4,000 times dx dt, which is 600. And that's going to give us 12,000. Oh no, 120,000. 120,000 minus 240,000, which equals a negative 120,000. Okay, and that's your value for the change of revenue with respect to time. Okay, so now we need to find the change in your profit. So we know profit equals revenue minus cost. And if we take the derivative of each of these terms with respect to t, that's going to give us the derivative of p with respect to t equals the derivative of r with respect to t minus the derivative of c with respect to t. And for these two terms, we already have a value. The rate of change in your cost with respect to time was 18,000 up here, and the change in your revenue with respect to time is the number we just calculated, negative 120,000. So we're just going to plug those values in. So this is going to equal negative 120 minus 18,000, which is going to give us a negative 138. Okay. And so you're going to determine that they're increasing or decreasing based on the sign of your value. So part A, costs are increasing at a rate of $18,000 per week at this production level. Revenue is decreasing at a rate of $120,000 per week at this production level, and profit is decreasing at a rate of 138,000 per week at this production level. Okay, so that's 41. That's a good problem to study. There's a lot of little steps. Okay, let's keep going. 42. Okay, so we are given a retail store estimates that weekly sales S and weekly advertising cost X, both in dollars, are related by S equals 40,000 minus 20,000 E raised to the negative 0.0004X. Current weekly advertising costs are $2,500, and these costs are increasing at a rate of $600 per week. Find the current rate of change of sales. Okay, so we weekly sales. Okay, so our S function is our sales function. So S equals 40,000 minus 20,000 E negative 0.0004X. Okay, so we need to find, oh, let me write some information down first. Okay, so the weekly advertising costs right now are X equals 2,500, and the rate of these costs per week are increasing by 600 per week. Okay. So the first thing we're going to do is take the derivative of this function. We need to calculate the derivative of S with respect to time. The derivative of a constant, it goes to 0, minus the derivative of this E value, it's e to the x times the derivative of this exponent. So that's going to look like negative 20,000 e to negative 0.0004 x times boom, boom, negative 0.0004 times the derivative of x with respect to t. Okay, this is just information to the side. Okay, so now I'm going to multiply 20,000 times this decimal. That's going to give me 8. 8e raised to the negative 0.0004x times dx dt. So here we already know our value of dx dt, and we know our value for x. Okay, so we're just going to plug that in and calculate our value for the current rate of change of cells. 8e negative 0.0004 times 2,500 times 600. And that's going to give you 1765.82, and we're asked to round to the nearest dollar, so that's going to equal 1766. Okay, now let's move on to the next question, 43. Okay, so 43, we're given a function f of x equals 100x minus 0.4x squared, and we're asked to calculate the relative rate of change. This is a toolbox. So relative rate of change is f prime of x divided by f of x. Okay, so we have our f of x. We're going to find our first derivative, and then we divide by our original function f of x. So f prime of x equals 100 minus 0.8x, and then we're just going to divide by f of x. So 100x minus 0.4x squared. And that's it, guys. This is your function for the relative rate of change for f of x. And let's move on to 44. We are doing the same thing for 44, finding the relative rate of change. So 44, you're given function f of x equals 192 minus 2x. So we're going to find the first derivative. Give me 1 second, guys. Okay, so we are going to find the first derivative. And that's going to be, this is a constant, so that goes to 0. So we're just left with this term, and the derivative of that is a -2. And then we're going to divide by f of x. So we're just going to bring that original function into the denominator. And that's your relative rate of change for this given function. Okay? Okay, so that's the end of question 44. Let's keep going. Home stretch, guys. I know it's a long one. All right, 45. Okay, find the percentage rate of change at the indicated value of x. Okay, so we're going to do the same thing first by calculating the relative rate of change, and then multiply by 100 to get the percentage rate of change. Okay, so we're given the function f of x equals 141 plus 36x, where x equals 9. Okay, so f prime of x equals the derivative of this constant goes to 0, so we're just left with 36 divided by f of x is going to be the original function, 141 plus 36x. Now we're going to evaluate this at x equals 9. So 36 divided by 141 plus 36 times 9. That's going to give us 36 divided by 465. And then we take this value that we're going to get here. Hold on, let me grab my calculator. Okay, 36 divided by 465. It gives us that decimal, and then we multiply by 100. And that's going to give us, to the 10th place, 7.7%. Okay, and that's it for question 45. Okay, now problem 46. We are given the function x equals f of p, which equals 30,000 minus 1100 p. And we are asked to use the price demand equation below to find E of P, the elasticity of demand. Okay, so what are we going to do? Okay, so the elasticity of demand, we need to use function E. This is a toolkit note. E of P equals P times R relative rate of change. Okay, so P times F prime of P divided by F of P. Okay, and this is our F of P function that we are already given. Okay, so all right, let's get into this. So the first thing I need to do is E of P equals P times the derivative of f of p. So the derivative is going to be negative 1100. And then we divide that by the original f of p. So 30,000 minus 1100 p. So I'm just going to rewrite this. It's 1100 p, 30,000 minus 1100 p. We are going to factor 100 out of each of these terms. So that's going to look like negative. I'm trying to decide what I'm doing here. Oh, I made a notation error. This is negative p. So here I should have also had a negative p, and a negative times a negative makes this positive. Okay, sorry about that detail, guys. Okie dokie. So I'm going to factor out 100, which is going to leave me with 11p. And then same thing in the denominator, factor out 100. That's going to leave me with 300 minus 11p. Simplify. That leaves me with 11p divided by 300 minus 11p. And that's it. That is my elasticity of demand function. Okay, 47. Do we have enough space here? Yeah. Okay, so 47. The same thing. We have our f of p, and we need to calculate our elasticity of demand function, and then we're going to evaluate at this given value of p price, and then we'll determine if this particular product, whatever it may be, has if its demand is inelastic, elastic, or unit. Okay, so we are given X equals F of P equals 27,000 minus 40P squared. And we're going to evaluate at P equals 14. Okay. So same thing as before, we're going to follow this structure for elasticity demand. Okay. So E of P equals negative P times the first derivative of this, which is going to give me 80, negative 80 P all over the original function. 27,000 minus 40P squared. We're going to simplify this, and it's going to give us positive 80P squared divided by 2700 minus 40P squared. Okay, and so now I'm going to plug in my 14. Excuse me, guys. So 80 times 14 squared divided by 27,000 minus 40 times 14 squared. I'm going to put that in my calculator. Okay. So 80 times 14 squared divided by 27,000 minus 40 times 14 squared gives me 0.81837. Okay, so E of P equals 0.81837. And so we need to give ourselves a little toolbox. So elasticity function of demand. When for 0 less than E of P less than 1, your demand is inelastic. For E of P, notation, is greater than 1, your demand is elastic. And for E of P equal to 1, it's a unit. Okay, so for this number of E of P, we are less than 1, so our demand, our demand is within this range. So it is in, oh, sorry guys, I'm out of screen. Okay, our value is between 0 and 1. So our demand is inelastic. Okay, this is toolbox information. Okay, let's move on to 48. Okay, let's get back to problem 48. Okay, so 48, we are using the demand equation to find the revenue function, then graph the revenue function and indicate the regions of inelastic and elastic demand on the graph. Okay, so we are going to first calculate our revenue function. So R of P, okay, which is a function of your price times your demand. So your F of P, your demand function, okay? So we're given F of P. F of P is equal to 40 times P minus 15 squared. And we need to calculate R of P. So R of P equals P times 40 times P minus 15 squared. So just simplify this. R of P equals 40P times P minus 15 squared. And this is this part. This is your solution here, okay? And then they want you to graph the revenue function and indicate the regions of inelastic and elastic growth. So the first thing we're going to do is graph this function. We're going to get our calculator. We're going to type this in, 40x times x minus 15 squared. We're going to change our window to -2, 15, 0, and 21,000. Okay. And you can kind of see these numbers on your graphs that are given. This one acts crazy. I don't really know why it's being crazy, but it's being crazy. Okay, so we're just going to hit graph, and there's our function. So we know that graphs B and D are not correct solutions. Those are just your standard parabolas, right? This has this kind of tapered off behavior here on the right tail of your graph. Okay, and so then also we need to label based on the behavior, right? This is a positive slope, this is a negative slope. So we know when our E of P is less than, oh, let me write you guys a note. Hold on. Okay, so let's look at our graph. So R prime P, when that is greater than 0, so positive, that's your inelastic, okay, region. When your R prime P is less than 0, so this is again your slope. This you have a positive slope, this you have a negative slope. When you have a negative slope, it's elastic. So on this portion of our graph, our slope is positive. This part of our graph is inelastic. This part of our graph, our slope is negative, right? Less than 0. So this part of our graph, our revenue function, is elastic. Okay? And that's all you got to do for question 48. Let's keep going. We're almost there, friends. I know it's been a long one. Okay, 49. Oh gosh. Okay, a fast food restaurant can produce a hamburger for $1.15. Okay, so that's their price. The hamburger's $1.15. If the restaurant's daily sales are increasing at a rate of 20 hamburgers per day, so the rate of sales with respect to time are increasing at 20 hamburgers per day, how fast is its daily cost for hamburgers increasing? Okay, so we got to make our own cost function. We know our cost function is equal to P times S of T. Okay, and so now we're going to take the first derivative. Actually, wait. Price. I can plug in price here, right? Because that's already set. So C of T equals 115 S of T times S of T. I'm going to take the derivative of C with respect to T and 1.15, the derivative of S of T with respect to T. Okay, so now I know this piece of information as well, right? So the derivative, I'm going to rewrite this, of T equals 115 S with respect to T. Okay, so I have both of these pieces of information, the price of the burger and the rate of increase of sales with respect to time. Okay, so I can plug both of those pieces of information in. And so dc of dt equals 115 times 20. And that's going to give me, I need a calculator, 1.15 times 20 is $23. So the daily cost for hamburgers is increasing at a rate of $23 per day, given that they're increasing their sales by 20 additional units of hamburgers. Okay, the last one, 50. Okay. 50, the price demand equation for hamburgers at a fast food restaurant is given by the equation below. X plus 300p equals 3,000. Currently, the price of a hamburger is $4, so P equals 4. If the price is decreased by 20, so the change in price with respect to time is 20. Is 20%. Okay. How will the revenue be affected? Okay. So the first thing we need to do is calculate our relative elasticity of demand. Okay. So I need to calculate E of P, which is equal to negative P times F prime of P over F of P. Okay. In order to find F of P, I need to solve for X. Okay, so I'm going to do that off to the side. So X minus, or plus, I'm sorry, plus 300P equals 3,000. I need to solve for X. So X equals 3,000 minus 300P. Okay, and then this is my F of P function. Okay, then my F prime of P is equal to negative 300. Okay, so now I have all my pieces of information to start plugging in. So E of P equals negative P times F prime of P, which is negative 300, divided by F of P, 3,000 minus 300P. Okay, so I'm just going to rewrite this. 300 divided by, I'm going to factor 300 out of both of these terms. So that's going to give me 300 times 10 minus P. The 300 is going to cancel. So E, oops, there's a P right here too. I forgot to bring down. Okay, so E of P equals P divided by 10 minus P. And we know that our price is $4, so we can evaluate this at 4. So E at 4 equals 4 divided by 10 minus 4. That's 4 divided by 6. That's going to give me, reduce that, that's 2/3. That is less than 1, right? Okay, so let's write some more toolbox information. Okay, so let's write some notes. So when your elasticity of demand is less than 1, you have your demand is inelastic. A price increase will result in a revenue increase, versus likewise, a price decrease will result in a revenue decrease. When your demand is elastic, your price increase results in a revenue decrease. When your price decreases, your revenue increases. Okay, so toolkit. Okay, so for this problem, we know that our demand is less than 1, so the demand is inelastic, and we know the price is going to decrease by 20%. So the price is decreasing, which means our revenue will also decrease. And that's your answer choice, okay? And that's it, guys. We made it to the end. I know this one was very long. If you guys have any questions, let me know. Send me an email. Pay attention to all the toolkit notes that I included throughout the video. And if you have any questions, please bring them to our in-class lecture or email me or come to tutoring. All right, guys, good luck.